Welcome everyone. Let's take a look at this series. We're going to determine whether the series converge or diverge. Now for this particular series, we can actually find if it is convergent, we can find its exact value. So here's how we're going to do this. Now, if your AN, so here's our AN, that's the formula. If it is given as a rational form, then you can actually write it out in a simpler fraction by decomposing using the partial fraction decomposition that we learned for integration. We can do that here because we have 3 over n squared plus n, so we can actually write that in simple fraction. And then we can write out the nth partial sum, take the limit of that. If the limit is finite, we know the sum is convergent. So that is the idea. The strategy here is to take the limit. So you want to write the limit as n goes to infinity of our, let's call this Sn. Sn will be the nth partial sum. And if this limit is finite, then we know the sum is convergent. So that is the strategy here. So let's go ahead and do that. So first, like I said, we're going to rewrite An by using the partial fraction decomposition. So hoping the terms as we write them out for nth partial sum, they will cancel out. So we can get a formula for Sn. So let's go ahead and do that. So we know our An is 3 over n squared plus n. And I'm going to decompose this. This is 3 over, factor out an n in the denominator, so you have n plus 1. And then we set up the partial fraction. So some a over n plus some b over n plus 1. So remember, from partial fractions, if the denominator is linear, the numerator is a constant term. It's 1 degree less. So here I have another linear factor. Here I have a constant. Now our goal is to figure out what is A and what is B so that we can go ahead and write out a few terms. So I'm going to go ahead and solve this side right here. So we're going to go ahead and multiply both sides of this by the least common denominator, which is n times n plus 1. So when we do that, on the left-hand side, we're going to get 3, but on the right-hand side, you'll have a times n plus 1, since n will cancel from the denominator, plus b times n. Now you can solve this whichever way you like, but I'm going to go ahead and solve by plugging in values of n. So if I substitute n equals 0, on the left side, you'll have 3. On the right side, you'll have a times 1 plus b is 0 because b times n is 0. So which will give us a is equal to 3. All right, so we got the value for a, wonderful. Now to solve for b, I'm going to go ahead and choose n to be -1. And the reason for that, if n is -1, this will disappear from the equation. We can successfully solve for b. So if n is -1, on the left side, we have 3. On the right side, we have b times -1, which will simply give us b is equal to -3. So not so crazy. We are able to solve for our constant terms successfully. I'm going to go ahead and substitute them right here. So we know that a is 3 and b is -3. So let's do that. That means now I can rewrite the sum because an, instead of expressing it this way, we can express it this way. That is the goal. All right, so let's do that. So I'm going to go ahead and rewrite. So we know our sum from 1 to infinity of 3 over n squared plus n is equivalent to writing n equals 1 to infinity of the sum of 3 over n minus 3 over n plus 1. Now that is a better way to express the formula of an, because now if you write out the nth partial sum, you'll see the terms will start to collapse. So that's why it is called the telescoping series. So go ahead and write out a few terms. So Sn, let's put S big N. So this will be the summing of, so we're gonna sum of these terms from starting from n equals 0 all the way to big N. So let's see how that's gonna look like. So this is going to be the first term will be when n equals 1. So you'll have 3 over 1 minus 3 over 1 plus 1, that's 2. So I'm substituting n values right here in my formula. And then the next term will be, so this is for n equals 1, the first term. Plus the next term is n equals 2. So when n is 2, you have 3 over 2 minus 3 over 4. Sorry, I made a mistake. 3 over 3. And then the next term, when n equals 3, you're going to get 3 over 3 minus 3 over 4. And then the next term is n equals 4 and so on. So you can keep going until the very last term. So the nth term right here, the big nth term. So that will be 3 over big N minus 3 over big N plus 1. Now, you might not see pattern yet or see which terms cancels, but what I'm going to do, I'm going to write out a few terms before the nth term. So for instance, I can write down the n minus 1th term. So substituting n minus 1 here and here in the formula, so that gives us 3 over big N minus 1 minus 3 over big N, because minus 1 plus 1 cancels out. Now, if you still don't see the pattern, you can go ahead and write down another term before it, maybe a big N minus 2th term. So this is the term before the nth minus 1. And that will look like 3 over n minus 2 minus 3 over n minus 1. I hope you see what's going on, and then this will pick up right here. All right, so this is our Sn, the first nth term. Now let's see what cancels. So you start to see terms will start to cancel. So by looking at what I have for Sn, so 3 over 2 and negative 3 over 2, they cancels. And then negative 3 over 3, positive 3 over 3 cancel. This one with whatever came after cancels. And you see that nothing cancels with this one. So 3 survives, 3 over 1 survives. Now, if you look at the last few terms, so this one right here, 3 over n plus 1, it doesn't appear anywhere here. So that means that term is not going to cancel. But 3 over big N minus 3 over big N cancels. This one with that one, this one with that one. So you see that all of these guys collapse. So our Sn, the nth partial sum, simply becomes 3 minus 3 over big N plus 1. So that is your Sn. And now we're going to go ahead and take the limit of this. So we take the limit as big N approaches infinity of 3 minus 3 over n plus 1. So as you take the limit using the limit laws, limit of a constant is a constant, so that will be 3. But the limit of this one, as big N gets large, we know that this will approach 0. So our limit is going to be 3 minus 0, or we can just simply say 3. So there you have it. This is a convergent telescoping series. And we know that the sum converges to 3. So that is a nice thing about this series. Okay, that's it. I hope this makes sense. See you next time. Take care, everyone.